Okay, welcome all to this webinar on advanced curve fitting in Origin. My name is Ishwar Iyer. Today I'm also joined by my colleagues Zheng Shah and Jennifer Swick. They are panelists. So during the webinar, feel free to type questions in the Q&A window to ask specific technical questions or use the chat window for general comments. Please don't send a private chat to the host, that is to me. I may not notice it in time, so please send the chat to everyone, to the panelists, so my colleagues can help as well. I will try monitor your questions as well as we go along and try to answer them. This gets asked often. We will share this project and we will share the recording. You may already know that on OriginLab website, if we go to originlab.com, under support, there is a link to webinars. And if I click that link, it'll take me to a page where you can see a list of upcoming webinars. So today's webinar, there is another one at 2 p.m. on advanced peak analysis by my colleague, James Chen. And next Friday, importing data and batch plotting. But there's lots more. If you click, you will see that we have the schedule for up to end of August, and we'll soon be adding webinars for September as well. If I go back to this page, you will see in the second section on the left here, you'll see a link for all recorded webinars. So here you'll see recordings from all of our past webinars. Just recently, we also put up many of the webinars on YouTube. So one of the benefits of that, let me just quickly show you. For example, user-defined fitting functions, how to define a user-defined fitting function. If I click on the YouTube link, it goes to the YouTube page, and I'm going to just pause it. What I wanted to show was if you click more, you'll see that we have broken up the video into sections. So if you come to any of these recordings that are on YouTube and you just want to see how to perform function with integration, you can just click on that timestamp and the video will skip to that section. So you don't have to wait to see where does function with integration start. So my colleague Jennifer Swick spent a lot of time doing this on YouTube. So much appreciated. So this would be very useful for all of you, I hope. In this webinar, I am assuming that you are fairly familiar with curve fitting in Origin. If you are new to Origin, I would recommend that you go back to the recorded webinars and find one of the old previous recordings on curve fitting. So if I scroll down here, I can find many recordings here. You can search through. There is advanced curve fitting that we have done before. Okay, there is curve fitting basics. So here's the one. This is not on YouTube yet, but you can preview this later if you are new to curve fitting. And we will be sharing this recording as well. So you may want to go back and review the basic curve fitting and then view the recording of this webinar. Okay. And towards the end, I'll also show you what's coming up in version 2021. I'm using version 2020B, which is our current released version, which was released in April. And 2021 will be coming end of October. And in that version, we are making significant improvements to Python, embedded Python in Origin. I'll talk about that later when we get to it. And that really opens doors for performing curve fitting beyond what's available in Origin and Origin Pro. Okay. One other note that some of the features I show here are available only in Pro. The difference between Origin Standard and Origin Pro is that the professional version has more advanced analysis features. And all of that, the differentiation is available on our website for you to look at. Okay. So today's agenda, I'm going to work through multiple exercises of some advanced fitting tasks. And for that, I'm going to use tools that are available in Origin, but I'm also going to use apps that are freely available for download. Okay. So as you may already know, on the right side of Origin, we have this apps bar. Okay, if it's not visible, you can go to the view menu and turn it on. If you click on the add apps icon, it opens what we call the App Center. And from this App Center, you can search for new apps. You can look what are new and popular. You can look for apps that you have already downloaded but are in need of an update because we published a new version and such. So if I click here, I have a correlation plot and image scale app which have been updated since I installed. So I can click and update the apps if I want to. Let me focus on search tab. So if I go to search, I can type keywords here. So for example, I can type fitting and do a search. And you will see that we have several free apps available for fitting. I will show some of them today. Okay. And these are all, each app has a minimum version requirement just based on the nature of when they were developed and published. So for instance, cyclic voltammetry app 2017 SR0, fit with composite functions 2019 SR0 and such. So these are all available. If you have the latest version, then they're all available to you, of course. Some of them require Pro just because the code is running a code base that's in the professional version. So feel free to explore this and install the apps and use them. And once you install an app, you can right click and place it in another tab. You can create a tab yourself by right clicking and say new tab. So I have put together several of the fitting apps, curve fitting apps that I will be using today in a separate tab called curve fitting. This just lets you organize the apps so that you have quick access to it yourself and you can decide what tabs you want. Okay. With that intro, let's jump into some exercises. I'm going to first start with fitting multiple data sets. Okay. So in this worksheet, I have 4 peak data and I have created a couple of graphs. They're just duplicate graphs. I just want to show you different ways of fitting this data. So let me double click and pop up this graph. Okay, as you know, a graph can be a floating window or it can be embedded in a worksheet, just like you can do it in Excel. There are several nice webinars on graphing that you may want to explore to see how multi-layer graphs can be managed very efficiently in Origin, how to set formatting and such. So here I have a 4-panel graph. So from this graph, I'm going to open the nonlinear curve fitter. For most of the exercises today, I'm going to focus on just the nonlinear curve fitter. Okay, open dialog. Note that there is a shortcut Control-Y to quickly bring it up so you don't have to go to the menu. Okay, so the first thing you do in the curve fitter is choose a function. I'm going to fit these data sets with the Gauss function. Okay, so under Origin basic function category itself, there is an entry Gauss. Or you can choose the peak functions category, which will show you all of the available peak functions in Origin. You can add your own functions as well. So let me choose Gauss. And what happened, if you look at the graph, is that Origin put an initialized curve only on one layer. My layer 3 happened to be the active layer. So for many operations, Origin typically goes to the active layer and the active data plot. In my case, I have only one data plot and just assumes that's what you want to fit. But you can override that. So let's go to data selection section. And here I want to show you the input data branch. And if I expand that, you will see there is only one range. Range in Origin is a group of cells. For example, X and a Y is an XY range, which is typically what fitting is used for. So I can click this flyout button at the input data level and say, no, I want to fit all plots in the active page, every plot in every layer of the page. If I choose that, Origin then will go examine my graph, find all the layers, find all the plots, and add all the ranges. Okay. Then you can drill down into the individual range. And just wanted to let you know, you can restrict the fitting by the row index, such as from row 10 to row 50, or by X, by typing an actual X value. Okay, if you have some spectra and you want to fit only a certain part of the data. There are examples of this in the basic curve fitting webinar, so I'm not going to go into that at length today. So now that I have chosen all of my data and chosen my function, at this point I can simply hit fit, and Origin will go through and fit them. Okay. And as you know, with any operation such as curve fitting or statistics or ANOVA or whatever, Origin creates a detailed report. So if I go back to my book, here is the report. And let's look at that report. So here is a parameter table for peaks 1, 2, 3, and 4. Okay, let me collapse that. And here's a statistics table. So you'll see that Origin reported a separate statement for each data set. So what just happened is that Origin took each curve and fitted it separately. It fitted curve 1, then moved to curve 2, then curve 3, then curve 4. So they have all been fitted independently. Okay, we call this independent mode but consolidated report. All the report got put together in one sheet, but each was fitted separately. So if you then go look at the summary, you will see that each value is unique. Nothing was shared. Okay, so that's one mode of fitting. But what if you wanted to take this data and perform a global fitting where you want to share some parameter? Let's say in this case, I want to share the width parameter. I want to force all of the fits to have the same width. I may know a priori from my measurement that they should all be the same width, more or less. So let's take this graph. I'm going to, which is just a copy of the previous graph, and I'm going to hit Control Y to bring up the dialog again. And this time I'll again choose the same Gauss function, and I'll go to data selection, and I'm going to again choose all active plots on my page. So it picks up all the ranges, and the initial guess curve has been placed. But this time I'm going to take a look at this drop down, multi-data fit mode. I ignored it last time. The default is independent fit consolidated report, as you saw. But if I click here, I have a global fit option. So let me choose that. If I choose that, what happens is in the parameters tab, an additional column appears for sharing. So this means I can share parameters. So you see for each peak, there is a center, width, and area, offset, center, width, and area. So I can go here and say, I want all the widths to be the same. So you see immediately the width parameter from peak 2, peak 3, and peak 4 disappeared. There is only one width parameter. So now Origin is going to take all of the data together and then do a global fit by sharing parameters. So it's not going to fit individually. It's going to jiggle all the parameters while fitting all the data sets simultaneously. Okay, so if I click fit, it'll again create a report. Okay, just wait for a minute for the fit to go through. Okay, now if I go back to my book, there is a second report here. If I now look at this report, if I look at the statistics, you will see that there is only one global statistic on the number of points, degrees of freedom, reduced chi-squared, and such, because all the data was treated as one single data set. And if you look at the summary, you will see all the width values are exactly the same because we forced the parameter to be shared across data sets. So this is global fitting. Maybe some of your data sets, it might apply to you. Okay, questions? Please feel free to type in the Q&A and chat window. Let's move on to another example, a pharmacology example, where sometimes when you make a measurement, a dose versus response, you may have replicate measurements. So I have 3 different measurements from the same experiment. So one can, of course, take these 3 columns and make a mean and standard deviation. There are ways to do that using, for example, descriptive statistics stats on rows. But sometimes users want to fit the raw data, not create a mean and standard deviation. So let's see how to do that. So I'm going to select all these three columns and fire up the fitter, Control Y. Okay. And I need to choose a function. Let me go to growth sigmoidal category and choose the dose response function. And now you'll see there's a preview down here. Origin is still treating each curve independently, so it's drawing 3 preview curves. I don't want to treat it like that. So let me go to data selection. And this time, remember, because I selected all the columns before bringing up the original, I want to fit all of them. So it populated all 3 ranges. I don't need to go here and select. But there are options here for selecting from the worksheet, selecting from dialog, and many such options so that you can add data sets. So my intent right now is to do a concatenate fit. We call it concatenate fit. What that does is it takes all the data sets, adds them all together as an individual data set, and then it's going to fit a single data set. So you'll see here that the preview already changed. It's still showing the raw data. Okay. I can override that. I can go to fitted curves and I can say fit the raw data, but when you present the results, please show to me as mean plus standard deviation. So it is fitting the consolidated combined data, but just representing the result as a mean and standard deviation data set and the fit curve. So if I go ahead and do a fit now, it's going to run through and do that concatenate fit and generate the report for me. Okay, so if I go look at the report, if I double click here, you will see what we saw in the preview, but now of course with the final optimized parameter. Okay, just wanted to point out that if you are into dose response fitting, we have a nice assays template in the worksheet dialog, new worksheet dialog. So if I go to file, new workbook, there is a dialog called new workbook, which has many templates. One of them is an assays template. These are pre-configured templates that you can open and start using right away. So this one has buttons for configuring your data set, selecting the function, executing the fit, and provide a fitting graph and such. I'm not going to go into the details of this, but it basically can do replicate fitting. We also have an enzyme kinematics fitting app if you are interested for doing curve fitting for pharma type data. Okay. Okay. Somebody is asking, is your project file available somewhere so I can have a hands-on practice? We suggest you don't try to run Origin and follow us the same exact time we are present in the webinar. That's not very productive because you will be distracted and we'll have to wait for each one of you to finish step 1, step 2. Doesn't work well, which is why we give you the project and the recording later. And we always are there to help you. Tech support is there to help. You can say, I attended yada yada webinar. I'm still confused about this particular tool. Here's my data. Help me. Okay. All right. Moving on. Next example, I have here data from a pharma type measurement where I was using, the customer was using rather, well plates, and there are 96 data sets. Okay, I want to fit them all individually one by one, not a global fit, just a run through fit. And I don't want to create a complicated, complex report with many tables and such. I just want a simple table. And I want the fit to happen quickly, and I don't want to go into the NL fit dialog and use settings. So for that purpose, we created an app called Speedy Fit. Okay, so with the workbook active, let me click on that app to launch it. And what it does, it assumes that you're fitting all the data in the active worksheet. Okay, that's the assumption. And I have choice of linear versus polynomial versus nonlinear. In my case, I need a nonlinear function and I need an exponential function. And there are many exponential function choices. Asymptotic one is the default, the first one, alphabetic. So that happens to be the appropriate function for my data. That's what the customer told us. So if I then click fit, it will fit the first data set and it shows that did it converge. Then I can click the next dataset button, examine the next one and click fit. Did not converge, just the nature of the data that happened to be a bad well in the plate. Next data, okay, click fit. So this way I can explore my data, quickly look through to see how my data is varying from one column to another, and try a few fits if I need to fix some parameter or put a bound. I can do all that to adjust everything. Then I can decide what reports do I want. Do I want the lower confidence level? Do I want the upper confidence level on the parameters? Do I want t-value? All that. And once I choose that, I can simply click OK. Origin will just zip through all the 96 columns and create a simple report for me. So if I look at this report, here is the data set in the first column, and here are all the values for a parameter A, value standard error, 95% lower confidence, upper confidence, and such. Also, it creates another sheet where there is an embedded graph. If I double click that, you can see, let me just move this table out of the way. This table can be customized to show only the parameters that you really want to show. I'm just going to put it a little bit to the side. Let me make the graph a little smaller. Okay. And this graph is a template with some buttons. So I can click the button here and flip through all of my data sets to see what was the final result. Okay. Not just look at the table, I can interactively examine my data. So this is a really cool app. Many customers liked it. So if you have a large number of data sets that you routinely fit with the same function, you might want to look at this. Okay. Moving on. Bounds and constraints. Okay. Sometimes when you perform fits, the fit may not converge given the data and the model, and you may want to go in and massage the fit by putting in certain bounds and constraints on your fit. Other times you may do that to keep the parameters within sensible range from your measurement and your field and what it is that you're studying. You may a priori know what are valid parameters. The fitting process is an iterative process. It doesn't know what your data is. It just tries to jiggle all the parameters to every possible value to find an optimal solution. So it's the user's responsibility to go in and put bounds and constraints when the parameters don't make sense and when you want to limit the range of the parameter value. So let me run through some examples here. So I have exponentially decaying data. I want to fit this with a two-term exponential function. Okay, let me hit Control Y to bring up the fitter. And over here, I'm going to choose exponential category. And my data doesn't have any offset to it. It starts at 0. So I'm going to choose the simple exponential decay 2, x decay 2 function. The fitter can show you the formula and the sample curves down here. There are tabs for that. So this just has an offset parameter, no offset in the x. Okay, so let me just fit with this. There are buttons in the fitter for various tasks such as computing chi-squared, single iteration, multiple iteration, and such. Let me go to the parameters tab, and I'm going to click this to fit until converge. So if you look at the messages tab, it clearly says 8 iterations were performed, fit has converged, the tolerance value was satisfied for the chi-squared minimization, everything looks good. Okay, I have a very good R squared 0.99. Okay, and I have the parameters here. So I have two time constants. Okay, there's an exponential decay, remember, with two terms, time constant 1, time constant 2. But what if I really wanted the first time constant to be the longer time constant and the second one to be the shorter? And you notice one of them amplitude is larger and the other amplitude is smaller. So how do I rearrange them? One way to do that is I can put bounds. So I can come here and say my T2. So this is the bounds tab. This is the parameters tab. Here is the bounds tab. So I go to the bounds and say, I want to force T1 to be greater than 5. I know it has to be greater than 5. I want to force T2 to be less than 1. Okay. I can double click through here to cycle my choices, less than 1. Okay. And I can double click here again to force it to be greater than 5. Now, if I do the fit, you will notice that it will flip the parameters. So now the first one is the longer time constant and the second one is the shorter time constant. I just wanted this order and I was able to achieve it by just putting bounds. Okay, just a simple example of bounds. What if I now want to constrain it further? I know from my measurement that the second decay should be equal in amplitude of the first decay, and the second time constant should be 1/10 of the first time constant. Okay, let's see how to force that. So to do that, I can't do that with bounds because multiple parameters are involved. Then I go to the code tab and I go to constraints. Okay, so here I want to put a constraint saying A2 less than A1 times 0.5 or T2 less than T1 times 0.1. Okay, so let me put that in. So I go here and say A2 less, let me quickly look at that. A2 less than A1 star 0.5 semicolon. Next line, T2 less than T1 star 0.1 semicolon. Okay. And one important thing, when you do these constraints, you have to enable them. This checkbox lets you flip the on-off status so you can study the effect. So now if I go to the parameters and click the fit, these values are closer to each other, 48 and 96, right? Almost equal, okay, 0.50 and 5.05. I can go back to the code and instead of a less than, I can force it, okay, to be equal, okay? And now if I click fit and go look at the parameters, you will see it's exactly 1/2, 96.13, 48.06, 5.0575, 0.5057. Okay, so just to show you the possibilities of using bounds and constraints to limit the range of parameters for your data and also for controlling the parameter values to sensible physical values that you may a priori know as appropriate ranges. Okay. There is an app for performing such fitting across multiple data sets with mixed functions and such. There are many such apps. So I would recommend that you check out the apps and find the ones that are most appropriate for your needs. Okay, let me see questions. Okay, question is about connecting points with smooth lines. That's more about a graphing task. It's not really a fitting task. So I suggest you review graphing tutorials, okay, and graphing webinars. Now let's go through some examples of forcing a data set through a certain data point. This comes up often enough in tech support that we thought we will show you a few examples, okay? Somebody's asking, is there a way to fit multiple data sets with some common parameters, some varying ones? That's exactly what I showed in global fitting. So please go back and review the recording. And if that wasn't clear, send your data over to tech support and we can help. Okay. So here I'm going to go through a couple of simple examples. Here I have a linear fit I have already performed, and my data point at x equal to 0 happens to be exactly y equal to 100. And I want to force this line to go through that point. With linear regression, it's simple enough. I can click here and do change parameters to bring back the dialog. You may already be familiar with Origin having these operation logs. Whenever you take an input and create an output that's related by an operation such as curve fitting, there is a log that ties the two together. I can click on the log and bring back the dialog with the exact settings I used at the time of my analysis. Then I can make changes. So I can go to fit control here and I can say, I want the intercept fixed. And I want it to go through exactly intercept of point y equal to 100 and click OK. Okay, then you will see the fit updates and the point goes through exactly 100. If I go look at my report, you will see my intercept is 100 and my standard error is zero, missing value because I forced my intercept to be fixed. Okay, when a parameter is fixed, there is no standard error. Okay, that's a simple enough case. But what if my function doesn't lend itself to a parameter that can force the curve to go through a data point? So here I have a parabola fits to some data, and for whatever reason, I want the parabola to go exactly through this fifth point. There isn't such a parameter in my function. So what do I do? So for that, you can apply weighting. Okay, you can weigh each point differently. So let me add a column here to this worksheet. And I'm going to enter a value 1 for all of the points. But the fifth point, I'm going to give it some extra weight by entering, say, 10,000. Okay, so I'm saying this point is particularly important, give it more weight when fitting. Okay, nothing changed in the graph because I haven't told Origin about the weighting yet. So let me click on the log and do change parameters. And here, what I need to do is I need to go to my input. Okay, and in my input, I have the X and Y chosen, but I also have a Y error. I'm going to choose the column C that I just added as the Y error. Then if I go to fit control, it will let me decide how to treat that error. Do I use it as an instrumental error? Do I use it as direct weighting? So in my case, I'm using direct weighting. Each error value is directly applicable to the data, not 1 over square of the error. Okay. So let me choose direct weighting and click OK. And now the fit will update and will force that curve to go through that data point. Is that appropriate to do? Yes or no? That's your decision. Often customers ask for this. Okay? So now the nonlinear curve fitter also has this option. And with the nonlinear curve fitter, there are many other options for error weighting, inverse weighting, direct weighting, and such. So I recommend that you look that up if you have weighting involved with your data, and then you want to apply that weighting. So in this context, I just wanted to force the curve to go through a particular data point, and I used weighting as a trick to do that. All right, moving on. Here I'm going to show you how to perform fit and find new X and Y values. Okay. So rather than starting from the scratch, I wanted to show you this Learning Center dialog. And this dialog can be opened from the Help menu, okay, or by pressing the F11 key as a shortcut. And this dialog comes with many examples. So if you're new to Origin or you just upgraded from an older version of Origin to a more recent version of Origin, this dialog is really useful. You have a tab for graph samples. You can go here and review what type of plots are available. For example, we added parallel alluvial Sankey diagrams in recent versions. You can go choose all plot types, and you can go here and type a keyword such as 2020B and do a search. It will show you all the plot variations and new plot types that were introduced in the latest version. And you can open any one of them and try the same plot with your data. My focus is on the analysis samples. So here you have many different categories again: batch plotting, batch processing, signal processing, peak analysis. My colleague James Chen will be doing the peak analysis webinar at 2 p.m. Don't miss that if you are into peak fitting. So I will stay with curve fitting here, and I'm going to choose calibration curve and unknown samples and open that. So this is a pre-configured sample, and in this sample, we have taken some data set and already performed a fit to show you what's possible. So what I have in my raw data is some concentration of some chemical and the absorbance peak for that particular concentration value. So these are all known samples. I know the concentration is 0.25. I popped that into the spectrometer. I did a peak analysis and my peak was 0.28. I changed my concentration to 1. I got 0.39. Change to 1.5, I got 0.546 and so forth. So these are all known samples. So here I have already done a linear regression. The green points are the data points and the red line is the regression line. And then in the regression, let me bring up the dialog. In the linear fit dialog, there is a tab called Find X, Find Y. The purpose of this tab is to let you find new X values or new Y values from your data. Find Y from X is trivial. If you have a new X value, how to find the Y value? Just use the fit line and the parameters. Origin will do that for you. I haven't checked that. More interesting is find the Y X value for a given new Y value. So in the context of this measurement, let's say somebody walked up to me and gave me an unknown sample. They don't know the concentration of that sample. I pop that into the spectrometer. I measured the peak. I got a peak value, which is my Y, but I don't know the X. So and I want to know the X, and I want to know it with a 95% confidence interval. So when you check this box and do the analysis in Origin, and by the way, this tab Find X, Find Y is available in the nonlinear fitter as well. What Origin does is Origin creates an additional sheet in the book called Find X from Y or Y from X, depending on what I chose. So I have already put some values here. Okay. So now let's say my colleague walks up to me and gives me a new sample, and I put that in the spectrometer, and my value turned out to be 0.7234 from the measurement. So then Origin will immediately calculate the X value and tell me that the X value is 2.5, the lower confidence level is 1.9, the upper confidence level is 3.07. So that's a very useful thing to have when you're measuring an unknown sample. And this graph has just been configured to plot this exact data into the graph as blue points. How to configure the graph? I'm not going to go into details of that. That's more of a graphing webinar. Okay, just wanted to focus on this Find XY sheet capability so that once the fitting is done, you can put in new Y values and calculate X values from the Y values using the fit equation as the guide. Okay. Let me know if I'm going too fast. There are quite a few examples I'm running through here. Okay. And the idea here is to give you a flavor of what's possible. Okay. So you can then explore these features and then look at what's suitable for your data. Please do not chat privately with me as the host. I may not be able to see it. Okay, I recommend that you put it in the Q&A window or the chat window. Okay. All right. Now I am going to move on. I was thinking of showing you user-defined fitting functions, but I'm going to skip that today because that has already been done by my colleague, and there is an excellent recording of that. So let me just click this link to open the web page, or rather I can just go to the web page here. And just recently there was a recording, a webinar on let me find it, user-defined fitting functions. It's already on YouTube, broken up by the topics and such. So I recommend you go review that. I would rather focus on some other topics for the rest of the webinar today. Okay, so let's move on and go to ranking models. And this comes up often. Okay, we get asked the question, I have done a fit, how do I know if this is a good fit or not? And the honest answer to that is, if you take one data set and fit with one function, you should not really be asking the question, is this a good fit? There is no good statistical answer to that. The more valid question is, I take one data set and fit with two or more functions. Then I can ask the question, which model is statistically more suitable for my data? Comparing the results. So here what I have done is I have taken some exponential data and I have fitted it with a single term exponential decay, the red line, and a two-term exponential decay, the green line. And you can clearly see visually that the red line did not portray my data well, whereas the green line did a much better fit. And you can see the R squared value improved from the red line to the green line. So then the question is, do I keep adding more terms? Or what about a 3-term exponential decay? What about a 4-term exponential decay? So to answer that question, you can do a rank model. Okay, so let's go back to the data here. And there's a rank models app. So let me fire that up. Okay, and this app is pre-shipped with Origin. It's already under the fitting menu. I just launched it from the app bar. So the idea here is you take the input data and then you select your functions. Okay, there are many categories here to select from. I can click and select a particular category. So in my case, I want exponential functions. And then all the exponential functions are shown. I can come here and decide, do I want 1 term, 2 term, 3 term? Do I want 1 term with an offset? Do I want 2 term with an offset? I can choose as many as I want here. Then what Origin does, once I decide what output should be, there are videos on this particular app, so you can play the videos to learn more. I'm quickly showing you. If I click the apply button, what Origin is going to do is it's going to take that data set and fit it with all the functions that you asked for. And then it's going to compare. Okay. And the way to compare, the best way to compare is a statistical entity quantity called Bayesian information criterion. Okay. This tool reports 2 criteria, AIC and BIC, a Kaike information criterion and Bayesian information criterion. The idea is the lower the value of BIC or AIC, the more appropriate is the model. Okay. So what this analysis just told us is that XDEC2, a 2-term exponential decay with no X offset, is the best model. The next best model is a 2-term exponential decay with an X offset. A 3-term exponential decay is the third choice. Okay. And the 3-term with an offset as well as a 4th and such. So looking at this, if you're not sure which of these models to use, the statistical test is telling you go with XDEC2. So I just wanted to make clear that you cannot ask, again, make clear, you cannot ask the question, fitting one data set with one function, is it a good fit? Comparing models to a single data set is the more appropriate question to ask. Okay. All right, moving on. Let's go to some examples of advanced fitting in Pro. Some of the features I showed you earlier, such as rank models, is available only in Pro. This is implicit fitting, surface fitting. These are also available only in Pro. I'm going to show you quickly these examples. So let's say you have a data set that has both X and Y errors, and you want to fit with the function that's not of the form y equal to f of x, rather it's of the functional form f equal to function of x and y. So for example, an ellipse. In many versions ago, Origin only had the least square minimization method, Levenberg-Marquardt method, where the minimization is done in the y direction only. Okay. Some versions back, we added orthogonal distance regression. What this lets you do is minimize the perpendicular distance from the data point onto the fit curve. So this takes into account variations in both X and Y. In other words, it can account for errors in both X and Y. Okay. So that's why we are using, in this case, the orthogonal distance regression for computing the fitting for the ellipse. So I'm going to go to the analysis menu and choose fitting. And under fitting, you will see there's a nonlinear implicit curve fit. It's essentially the same tool, but with a function category that's only available for implicit fitting. And the iterative algorithm is frozen to orthogonal distance regression. Just a point of note, you can use the ODR algorithm with regular functions of the form y equal to f of x if you have error values in x as well, using the regular fitter. That's available as well. Okay. In this case, I need to use both x and y, and my function is the form f equal to function of x and y on the right side. Okay, so then I can simply click fit and I can get an ellipse fit to my data. Okay, let's move on to surface fitting. We have a few tools for that. This one came from an engineering customer. They have 3 columns of data x, y, and z, and they wanted to fit different orders of polynomials in x and y and find out which is the best fit. So we created a tool for that called polynomial surface fit. And I'm going to open that. And there are several options here. I can consider up to 4 terms in x and 4 terms in y. And I can say rank it using the Bayes information criteria and click OK. And then Origin will do all the fits and then give me a report sheet where it rates them all, again using the same BIC criterion, and it has marked the best value, the lowest value. So it's telling me a polynomial with order 3 in x and order 3 in y is the best fit for this data set. Okay, again, the question to ask is not take a single polynomial and fit, but do multiple polynomial fits and rank them. Okay, and this is an example of peak fitting. I'm going to skip this because my colleague James Chen will be doing peak fitting and he may do a 2D peak fitting example. Okay, it's possible to fit 2D peaks such as a Gaussian 2D, a Lorentz 2D, and such in Origin Pro as well. Okay, let me move on and show a couple of other popular fitting questions that come up often. Okay, one is, what if I have some data where there is some transition? It's linear for a certain part of the data and then it decays. Maybe I'm using a catalyst or something that controls my reaction and the behavior change. There's a phase 1 and a phase 2. In Origin, you can freeze the data set, you can chop up the data set and fit them separately, but then the fitted line may not go through that point, may not meet at that point. So for that purpose, we created a Piecewise Fit app, which will take care of that issue. Okay, so if I go to the Piecewise Fit app, this app lets you choose up to 3 segments in your data. I have only 2 segments now. I can use the same function for all of the segments, such as say a linear fit, but with different slopes. But in my case, my first segment is polynomial line, and second segment is exponential decay, a single term. And then Origin finds the x value at the intersection of the 2 segments automatically. If you a priori know the value, you can fix it, or you can leave it float and you can click fit, and you know that it did a nice fit here. The R squared value is very low, very high. The chi-squared value is very low. In 5 iterations, it found the fit. And if I click OK, it gives me a nice graph, and it gives you this point where the 2 curves meet. Okay, and then you will get a report. Okay. Okay, here's a report sheet that clearly shows which was the intersection point and what was the equation used for the first part and the second part. Okay. Another question that comes up often is fitting with convolution. Okay, so let me take a few moments to explain that. When you perform a measurement with an instrument, the instrument's response function can distort what you are measuring. So in my case, I am supposed to be measuring an exponentially decaying phenomenon, but my instrument happens to have a broad Gaussian response. It's not an impulse, it's a broad function with a significant width. So what happens in my measurement is, because of that, my measured signal is distorted. Rather than a pure exponential, I have something that looks like a peak at the beginning and then decays. So essentially, my measurement got convoluted with the instrument's response function. How do I separate it out? One way is to do deconvolution. Origin has a tool for that, but it's not a mathematically safe thing to do. Because when you do deconvolution, you're essentially taking FFT of the signal, FFT of the response, and doing a division. And division with small numbers in the FFT can blow up, creating noisy results. So what instead is to perform the convolution while you're fitting. So you fit with an exponential function while the iterative process is going on. At each step, Origin takes the response function and folds it into the fitting process so that the fitting takes into account the response function. So here is my response that a priori I know, maybe the instrument maker gave it to you, or you did some blank measurement or whatever to generate the response function. And here is my measured signal. So with this worksheet, let me fire up the Fit Convolution app. And this app assumes that my first column is X, second column is the measured Y, and third column is my instrument response. Then here I can type in my function. In this case, I have an exponential function. So I'm going to type in A star exp of minus X star tau, tau for the time parameter, and click outside the box. Then Origin automatically looks at the data, already has some guess values, and you can see an initial curve here. I can go ahead and click the fit, and then it performed the fit successfully. In the process of fitting, convoluting the response into the fitting process. Okay, then I can click the fit report and get my result. Okay. Of course, this assumes that you have a known instrument response function. This has come up often. Many versions ago, you had to code this in Origin C. So we decided to make that into a friendly app. Okay, so if you go to the report sheet, again, you will get a standard report. Here's my final fit result with my parameters and my graph. So here, the decay constant that Origin is reporting is the true exponential decay, which does not get biased by the response of the instrument because the response has already been taken into account during the fitting process. Okay. All right. So now I'm going to choose to fitting with Python in version 2021. Quickly show you what's new, what's coming down the line. And to end, we'll come back and do a quick polling. And that's very important for us to get your feedback so we can understand from you if these webinars are useful and what webinar would you like to see in the future. So before we get into polling, let me fire up 2021 and quickly show you what's coming up in October with 2021. So in Origin, even in the current version and a few versions before, we introduced the concept of embedded Python. So what that means is you do not even need to go out and get Python installed. Origin automatically installs Python. It's an option during the installation. You can turn it off. It's on by default. Origin installs Python along with Origin. So Python is available to use immediately. What we are doing in 2021 is make the embedded Python work much better by adding a package, a new package for accessing Origin from Python for exchanging data, data frames, string data, and all that. Everything much easier. We are also adding capability for debugging Python code, managing Python packages. Everything will be much smoother compared to what is possible in the current released version. So with that said, I want to show two examples. One is Bayesian regression. Okay, so here I have some data. I do not want to fit it with a particular function. In my case, I may not even know physically what the function is. Instead, I want to use Bayesian ridge model. Okay, you can learn more about it by Googling or going to the scikit-learn page. So what we are doing here is using a package called scikit-learn from Python to do the computation. First, let me run the code. Then I will show you the code. So I click run, it did the fit. So here is a predicted value and the predicted band of the plus minus confidence values. So if I click show code, it's going to open code builder, which is our coding environment. And in this project, there is a file called blr.py that's attached, which did all the work. Okay, so this required NumPy, it required pandas, it required scikit-learn, and there is also this new package, Origin Pro. That's the package we are introducing in 2021. This is the package for interacting with Origin software from Python. So all of the code here, the fit lines are essentially these 3 lines. That's it. Okay, so you're essentially setting up a Bayesian linear fit model, calling the fit and calling the prediction function to get new y values for the x values. The rest is all just exchanging data using data frames, using pandas between Origin and Python to put in the data and get the data back after the fit. So the coding will be much simpler. It's in a more friendly platform of Python that most of you may be familiar with already. Plus, there are many, many examples of Python packages and Python functions out there. You can grab a code, bring it into Origin, just add the interaction part of exchanging data with Origin, and you're good to go. And we are always there to help you. Okay. Another example that my colleague James Chen put together just a couple of weeks ago, somebody asked how to perform a summation fit. So it was not fitting using one of the standard functions, but fitting using a summation of series. So here they have a particular series, and they had some specific constant values for the E1, E2, E3, and beginning values for G1, G2, G3 in this series, and then how to fit with that. So here there are some initial parameters, here there are some constant parameters, and the code in this case is just in the set column value. So if I click on this lock and do change parameters, in the previous example I showed that the code was attached to the project. Python code can even be attached to the worksheet inside a column. So we are introducing a new Python function tab in the set column values dialog. All of the code is right here. This is the specific function that the user had, all of their summation terms, and it's simply using SciPy optimize, using the minimize module in SciPy to do the optimization, to do the computation, and then just put it back into Origin. And it's a single line of call from Origin, py.runFit. RunFit is a function, and it's passing column A, B, C, and D and returning the values into column E and F for the fit result. Okay, so just want to give a shout out about what's coming up in 2021. If any of you are into Python and you want to play with this already, we have a beta release. Just email us and we will set you up with the beta version. Okay, so with that said, let me ask my colleague Jen to bring up the polling. So you can please give us your feedback. Your feedback is important for us to know what topics we should cover in future webinars. Okay. We appreciate you taking the time to join us today. This project and the recording will be available to you early next week. Okay. I'll leave the chat and Q&A open. You can still ask questions and put comments in here. And please answer the poll questions. Thank you. Just wanted to give a shout out to my colleagues in tech support. They are an excellent team. They are there to help. So when you run into a challenge with your curve fitting and you're willing to share your data and details, we are more than happy to look at. We also have an excellent R&D team who help to put together these apps. So we are there to help you. Don't be shy to contact us to ask for help.